Alright, you guys want to make sure when you guys are working on these that you write these down with me. You just don't simply watch me do the math. You do the math with me. Make sure you get your journal out. Make sure you write down the problems and follow it step by step. We're going to be doing a lot of factoring, canceling of factors. We're going to go and start with this problem. It has negative 7 n squared over negative 14 n squared minus 35 times n. Now what we're going to do is we're going to break this down into its factors because I want you guys to see kind of what we're doing here. So we're going to break this down into a negative 1, a 7, an n, and another n. So negative 7n squared breaks down to all these factors. Negative 14 n squared breaks down to a negative 1 times a 2 times a 7 times an n times an n. Those are broken down into its factors. Negative 35n breaks down into a negative 1 times a 5 times a 7 times an n. So all I've done is broken these down into its factors. It's prime factors, actually. Okay. So one thing we have to be able to do is I want you guys to look for some common factors in the denominator right here. Hopefully you guys can clearly see that they both share a negative 1 right here and right here. They both share a 7, and they both share an n. Now what does that allow us to do? That allows us to factor out a negative 1, I'm just going to put a negative, a 7, and an n out of the expression. So when I factor out a negative 1 and a 7 and an n out, all I'm left with is a 2 and an n. When I factor out a negative 1, a 7, and an n out of this expression, all I'm left with is a positive 5. Now, let's take a look at the numerator. The numerator, we have what? Negative 7n squared. But look, they also share common factors. It shares the negative 1, it shares the 7, and it shares an n. Now what does that allow us to do? That allows us to be able to cancel out. I'm going to rewrite it right now. We have negative 7n squared over negative 7n, open parentheses, and what we have left is we have a 2n plus 5. Now how can you check to make sure you factor things out correctly? Just use the distributive property. You'll notice that these products right here become negative 14n squared, and this product right here, negative 7n times 5, becomes a negative 35n. So you can use the distributive property to check your work. Now here's what happens. We have to figure out the numbers that make the denominator, all right? Which values of n make the expression undefined? Now what does that mean? One thing you can never have in the denominator is 0. You can never divide something into nothing. Therefore, the number that you could plug in here to make everything into 0 would be 0. Because 7 times 0 multiplied anything makes it equal to 0. The number that you'd have to plug in here to make this equal to 0 is actually negative 5 over 2. Now, how would I be able to figure that out if I was trying to solve for this? All you have to do is do 2n plus 5, set it equal to 0, and then solve for the value of n. By taking 5 away from both sides, you get 2n equals negative 5, and you divide both sides by 2, and n equals negative 5 over 2. Now, when you plug this answer into this equation, it makes the denominator equal to 0. So the two answers that make my expression undefined, it is undefined at n equals 0, and it is undefined at n equals negative 5 over 2. So I'm going to choose those two answers in the multiple choice section. That's the first thing I do, is I figure out what numbers make the denominator equal to 0. So step 1, okay? What did I do? I factored. All right, factored out what's called a common factor. Step 2, I figured out what answers make the denominator equal to 0, okay? So basically, what numbers make the denominator equal to 0. And step 3, the last thing I have to do is I have to simplify, which basically means I have to cancel out common factors. So cancel out common factors. And I wish my handwriting was better, but this is a board that is very difficult to write on. All right, so what are my common factors when I look at this? Basically, my common factors are 7n. I'm going to cancel out a 7n out of here and cancel a 7n right there. I'm also going to cancel out these negatives. So I'm going to cancel out negative 7n. When I do that, the only thing I'm left with in the numerator is an n. And the only thing I'm left with in the denominator is 2n plus 5. And that's going to be my simplified expression. Okay, so the very first thing I did was I broke down everything into its basically its prime factors. I factored out a common, what's called the greatest common factor out of this expression. I canceled out those factors. I'm left with a simplified expression, and I also figured out what numbers make the denominator equal to 0. So I'm going to go over here. I'm going to make a little fraction bar. In the numerator, I'm going to put n. And the denominator, I'm going to put 2n plus 5. And then I'm going to choose all the answers that make it equal to 0. So we found one of the answers that makes it equal to 0 is 0 itself, and also negative 5 over 2. Negative 5 over 2, and n equals 0. Alright, now what we're going to do right now is I'm going to type this into Desmos because I want you guys to see what a rational expression looks like. Okay, except we're going to use x, we're not going to use n. So I'm going to make a little division bar here. I'm going to type in negative 7x squared, and then we go back here, I'm going to put negative 14x squared minus 35. X. Yep, minus 35x. Now, we're going to kind of talk about some things here that you're not going to be accustomed to dealing with because we're just starting this. All right, so this is a rational expression. And the numbers that make this equal to 0, I'm going to type them in real quick. All right, you'll see 0, it's undefined at 0. All right, and Lisa also said it was undefined at negative 5 divided by 2. So anytime it's undefined, those are the numbers that make the denominator equal to 0. Now, one of the things we're going to do is I'm going to show you guys where we call what's called a horizontal asymptote. I'm going to go ahead and type it in. I'm going to put y equals 1/2. That's our horizontal asymptote. And we also have a vertical asymptote. All right, now our vertical asymptote is actually at x equals -5 divided by 2. All right, so we call this a vertical asymptote. We call this a horizontal asymptote. You'll notice if I zoom out, no matter where I go, this graph approaches both the vertical asymptote and the horizontal asymptote, and it kind of provides boundaries for the graph. We're going to be learning more about those as we continue to simplify and graph rational expressions. All right, so I realize this is a lot to take in. We'll kind of just do it step by step. We'll go and keep going through this section, and hopefully by the end you will have a better understanding of simplifying rational expressions. All right, so what we're going to be really working on right now is finding what's called the common monomial factor out of this expression right here. So I'm going to rewrite it. 12n cubed plus 48n squared all over 12n cubed plus 60n squared. It's really helpful if you know your multiplication facts, so that you can know like what numbers are divisible into other numbers. So that's going to be pretty important. Now, if you don't know your multiplication facts, something you can do with the graphing calculator is, for example, if you wanted to find all the factors of, say, 48, just go to your calculator. I'll clear this out. Hit y equals 48 divided by x and create a rational expression. And then check the table, and you'll find the numbers right here: 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. All of those are your factors of 48. If you wanted to find your factors of, say, 60, just do 60 divided by x, check your table. You can clearly see all your factors of 60. 1 is 60. Only look for the integers. You're not going to use 7 and 8 and 5/7. You're not going to use those. Okay, so just look for your integers right here. These are all of your factors of 60. So one thing I want you guys to do is, if you're not good with your multiplication facts, at least do the number divided by x in your graphing calculator and look at the table. What is the greatest common factor, what's called the GCF, of a 12 and a 48? The greatest common factor is 12, because 12 goes into 48. All right, and 12 also right here goes into 60. So we're going to factor out a 12. We're going to factor out a 12 in the numerator, and we're going to factor out a 12 in the denominator. Now, what does n cubed actually mean? It means n times n times n. So it'll let me write it the way I want to. And n squared means n times n. So what is the greatest number of n's that you can factor out of both of this expression and this expression? The greatest value is 2. So we can factor out a couple of those. So we're going to factor out what's called an n squared. And then we're going to open up parentheses and open up parentheses. Over here we can factor out n squared out of this, and we can factor out n squared out of this. So what does that leave me with? If I factor out a 12n squared out of this, all I'm left with is just one variable known as n. If I factor out 12n squared out of this, I'm left with a 4. Over here we have 12n cubed. If I factor out 12n squared, I'm left with an n. And down here I'm left with a 5. Now once again, how do we check our work? Use the distributive property to check your work. Make sure these products equal the first number, and these products right here equal the second term. 12n squared times n is 12n cubed. 12n squared times 5 is 60n squared. So by using the distributive property, we can check our work pretty easily. So what are the common factors that we can cancel out? What's the greatest common factor? Our greatest common factor was 12n squared. That's the common monomial factor that we can cancel out. So basically, all we have left is this right here. So if we over here, it says, which student wrote an expression that is equivalent to the original expression? Well, this student definitely wrote an expression that was equivalent to the original expression. This is not equivalent to our original expression, but this person definitely did. So I'm going to select only this person right here. All right. I'll do this one a little bit more slowly. Maybe the last one you didn't understand how to break down common factors, so I will break this one down into its common factors, or its prime factors, that is. My apologies. All right, so here we go. I'm going to break down the numerator into its prime factors. 9 can be broken down into 3 times 3. X squared can be broken down into x times x. 36 can be broken down into 2 times 2 times 3 times 3. X cubed is broken down into an x times an x times an x. And last but not least, 27 can be broken down, and put plus 3 times 3 times 3, that's 27. And x squared is broken down into simply x times x. All right, so once again, 9x squared is broken down into 3 times 3, which is 9, and x times x, which is x squared. 36x cubed is broken down into 2 times 2, which is 4, 3 times 3, which is 9, and 4 times 9 is 36. So all that equals 36, and we have x to the power of 3, which is x times x times x. And last, 3 times 3 times 3 equals 27, and x times x equals x squared. So what we're trying to do right now is we are trying to factor out what's known as a common factor. So let's take a look at, let's do a different color to find out a common factor that we can factor out of this denominator. It looks like I have a couple of 3's right here. I got a couple of 3's right here. Got a couple of x's and a couple of x's. So my common monomial factor that I can factor out of the denominator is 3 times 3, which is 9, and x times x, which is x squared. Now what does that leave me with? That leaves me with a 2 times 2, which is a 4, and then there's an x right there, plus, looks like the only thing I have left over here is 3. And then over here on top, right here, I have 3 times 3, which I still have what? I still have a total of what? 9x squared. So now, once I have this, what the next step, after I get everything factored out, this is called the greatest common factor. So I'll put right here for you guys, this is called the GCF, the greatest common factor. We got to figure out what numbers can we plug in here to make everything equal to 0. Well, one number we can easily plug in to make the denominator equal to 0 is the number 0 itself. So anytime you factor out an x or an x squared or an x cubed out of everything, you know one of your answers is going to be x equals 0. You know that for sure. The next thing we have to do is we have to set this expression equal to 0. So we just set 4x plus 3, set it equal to 0. Then you take away 3 from both sides, and you get 4x equals negative 3. Divide both sides by 4, and you get x equals negative 3/4. Now what does that mean? That means if I plug in negative 3/4 in right here, we make that expression equal to 0. So my other answer is negative 3/4. Now I've solved so many of these. Whenever I do this, I don't go through the process. I have a little shortcut, and hopefully you'll understand this shortcut. All I do is I take the negative version of this number and put it over this number right here. So I just put negative 3/4. I know I'm done. Okay. So what would that look like as an example? If I had, say, for example, 1 over 2x plus 7, what's the negative version of a positive 7? Negative 7. That was going to be negative 7 over 2. If I had 1 over 3x plus 8, I know my answer is going to be negative 8/3. The negative version of this number over this number. If I had 1 over 4x minus 15, I know my answer is going to be a positive 15 over 4. That would make my denominator equal to 0. So it's always the negative version of this number over this number. It's just a quick way to find those fractions that you need. So what is the fraction that I need? A negative 3/4. So my other answer is going to be this one right here, A and C. Now I got to finish simplifying. So hopefully you guys can see that this 9x squared is going to cancel out this 9x squared, and my final answer will be 1 over 4x plus 3. So that's what I'm going to type in. Where am I going to type that in? I'm going to type it in right here. So right here, I go fraction bar, type in 1 over 4x plus 3. Then I'm going to make sure I put in a x equals 0 and x equals negative 3/4 and hit check. Let's do one more problem and we'll call it a day for this particular video. I realize this one takes a little bit more time to watch and try to understand, so just do the best you can to follow along. We're going to find, once again, the common monomial factor. So 39 z to the power of 4, that is broken down into 3 times 13 times 1z. I write my z's with little slashes so you don't think they're 2's. So 39z to the power of 4 looks like this. 39z cubed one z, 2 z's, 3 z's. Alright, all over 13z cubed. 13 times z times z times z. So I've broken it down into its prime factors. So hopefully, let's look for some common factors here. This shares a 3, this shares a 3, this shares a 13, and a 13. I got a total of z cubed on this side and a z cubed on this side, which allows me to find what's known as my greatest common factor. My greatest common factor is literally 39z cubed in the numerator. Okay? So I'm going to factor out 39z cubed in the numerator, and the denominator I'm just going to leave it as 13z cubed. So what do we have left? All I have left right here is a z. Plus, if everything gets factored out, that means I have a 1 left. Now remember, how do you check it? Distribute to both to make sure that you did everything correctly. These products equal 39z to the power of 4. And 39z cubed times 1 is 39z cubed. Now, next thing I do is I find a number that makes the denominator equal to 0. And the number that makes everything equal to 0 is just 0 itself. Alright, so I'm going to look for the answer that has 0. And last but not least, now I just got to find what's divisible. 13 goes into 39 a total of 3 times. Z cubes totally cancel each other out. And here's what I'm left with. A 3 parentheses z plus 1. That's what I'm left with. Now, if you ever see they want it in what's called expanded form. If I expand this, that means I have to use the distributive property. So the other answer I could put in the Khan Academy, and sometimes you have to because it'll say, write it in expanded form. It'll be 3z plus 3. And that's what it'll be in expanded form. But right now it didn't ask for expanded form, so I can actually write it in factored form. This is called factored form. And it'll still work. Alright, so here we go. We're going to take this right here. Take that 3 parentheses z plus 1, put it right there. 3 parentheses z plus 1. And don't want to click those. No, there you go. Those are wrong. There's only one number that makes the denominator equal to 0, and that is just 0 itself. Alright? That's how it's done. Alright, we're going to be doing more complicated problems in the next video, but right now you got to learn how to factor out what's called common monomial factors, which are factors that are common to both the numerator and the denominator.